Hello, my dear students. Welcome to the class. Today we will discuss about the differentiation of symmetric infinite series. And before that, we have to know what type of series are called symmetric infinite series. In these types of function or series, an expression comes repeatedly, an infinite number of times in a certain pattern. For better understanding, let us do some problems involving symmetric infinite series. Here actually we do not have any new theory to differentiate these types of function. So let us take one simple problem to understand this. So you see a problem. So let us take this question. Find dy dx if y is equal to root over of x plus again root over of x plus again root over of x plus again root over of x plus and so on up to infinity. So this is a symmetric infinite series because this x, root x actually, this root x and again root x, again root x. So this is an infinite series and the term root x comes repeatedly in this series, and so these types of series are known as symmetric infinite series. So to differentiate these types of function, first of all, let's see in an infinite series, if we delete one term from the series, say if we delete this term from the series, then the series remains infinite. Or if we take one extra term in the series, in that case also this series will remain infinite. So let us consider this series without this x. Then you see here y is equal to root over of x again root over of x again root over of x and so on. That means these total terms can be replaced by y again. So therefore we can write like this, is implies if you square it, say y square is equal to, it will be x, this root over will eliminate x, plus then you see this is root over of x plus again root over of x plus again root over of x plus and so on up to infinity. So now you see this is implies y square is equal to x remaining same, plus again you see is it not is equal to y, so we can replace it by y. Now this is our function actually, y square is equal to x plus y, and it is very simple to differentiate, and you know the method to differentiate these types of function. So you write differentiating with respect to x. So left hand side is twice y, then for y it is dy dx, and that is equal to right hand side x derivative is 1, then plus y derivative is dy dx. Very simple. And then it is implies this dy dx shifted to the left, this one, and taking common, so dy dx whole term multiplied by twice y minus 1, actually this is minus 1, is equal to 1 is already remaining there. So that is implies dy dx is equal to, it is simply 1 by twice y minus 1, and you may leave the answer here. So this is the process actually to differentiate any function involving symmetric infinite series. So let us take one more example of this type. You take this question now, y is equal to root over sine x plus again root over sine x plus again root over sine x plus and so on up to infinity. So this is again a symmetric infinite series. So in the similar manner as you have done in the previous problem, you square it, so y square is equal to, it will be sine of x plus it is root over of this sine x plus again root over of sine x plus, since it is up to infinity, so you may write another root over sine x and plus so on up to infinity. So that is implies y square is equal to, it is sine x plus, now this total term can be replaced by y, so you can write y here. Now this is an implicit function, and so you can differentiate. So differentiating with respect to x. So left hand side is twice y dy dx is equal to the differentiation of sin x is cos x only, then plus differentiation of y is dy dx. Now this and this term taken to the left and taking common dy dx, it is simply twice y minus 1, and on the right side only cos x is remaining there. Now just divide this term. So that is implies dy dx will be equal to cos x by twice y minus 1. So that is the solution for the question. Note, so you have the function like this, y is equal to some root over of whatever be the function is given there, fx plus again root over of fx plus again root over of fx, then plus so on up to infinity. So in these types of function, whatever be fx is replaced here, যে কোনো বস্তু ইয়াতে fx এর ঠাই দিয়ে দিয়া একো প্রবলেম নাই. In all cases the result will be dy dx, you can write here, then dy dx is equal to, it is simply f dash x divided by always twice y minus 1. So this note is given only for your entrance exam. Entrance exam যদি তুমি এনে ধৰণৰ কোৱেশ্চনছ পোৱা তেতিয়াহ'লে খালি fx ৰ ঠাইত যেটো বস্তু থাকিব, say it is cos x root over cos x again root over cos x এনেকৈ আছে তোমাৰ, তেতিয়াহ'লে তোমাৰ আনসাৰটো কিমান আহিব, মাইনাছ sin x divided by twice y minus 1. এটা সলভ কৰিব নালাগে, বাট ইন আৱাৰ এক্সাম ইউ হেভ টু শ্ব' দ্য প্ৰচিডিউৰ, তুমি প্ৰচিডিউৰটো শ্ব' কৰিব লাগিব. কিন্তু এণ্ট্ৰেন্সৰ কাৰণে মই কৈছোঁ জাষ্ট যাতে এক লাইনত তুমি ফটককৈ এনচাৰটো লিখি দিব পাৰা. ফৰ ডেট ইউ হেভ দিছ নোট, এইটো নোটটো তোমাক মই দি দিছোঁ সেইকাৰণে. অ'কে, চ' ইউ কাম টু আনাদাৰ কুৱেশ্যন. সি দ্য কুৱেশ্যন ফাৰ্ষ্ট. So y is equal to x to the power x to the power x to the power and so on up to infinity. This is also symmetric infinite series because the term x is coming repeatedly. So this is a symmetric infinite series. So it can be right in the form of this x. This x is written here, and the remaining section, it is again actually x to the power x to the power x up to infinity. So that term can be replaced by again y. So actual function is y is equal to x to the power y. Now to differentiate these types of function, we have the method discussed in the earlier class. So the method was, since the function is given in the form of phi x to the power psi y, x to the power y, both are variable, therefore we need logarithm to differentiate this. So log of y is equal to, on the right side it is log y into log of x, taking log with the base e. Now differentiate. So differentiating with respect to x, left hand side will be 1 by y into dy dx. This is our left hand side, is equal to right hand side the product of two functions y and log x. So y derivative is dy dx into log x remaining same, then plus y remaining same into log x derivative is 1 by x. Then taking dy dx common from these two terms, so dy dx is common, it is 1 by y, then shifting to the left is minus log of x, and on the right side we have only y by x. This is y by x. So that is implies dy dx, taking LCM here, so 1 minus y log of x divided by y is equal to y by x only. And so from here you can write dy dx is equal to cross product, so it is y square divided by x into this total term 1 minus y log of x. So you may leave the answer here. So this is the process or method to solve the question involving symmetric infinite series. So let us take more examples. You see this question, y is equal to e to the power x plus e to the power x plus e to the power x. This plus is in the power, e to the power x, then plus again e to the power x plus e to the power x up to infinity. Then to prove that dy dx is equal to y y by 1 minus y. So we take the solution. The expression is given y is equal to e to the power x, then plus again e to the power x, then plus again e to the power x, then plus so on up to infinity. This is your function given. Now you see, if you do not think about this e to the power x, just you think y is equal to, so this total term can be replaced by y again. So therefore this is actually y is equal to e to the power x. This is written as e to the power x, same thing. Then the rest of the terms can again be considered as y, because this is again infinite series, symmetric infinite series, therefore it is replaced by y only. So this is our question now, y is equal to e to the power x plus y. So you can differentiate it, or by taking logarithm you can also differentiate. So let us take logarithm, it will be easier than the other method. So log of y will be is equal to x plus y alone, because x plus y into log of e is equal to 1, you know that log of e is equal to 1. So then differentiating with respect to x, so you will have the left hand side is 1 by y into dy dx is equal to, on the right hand side it is 1 plus y derivative is dy dx. Now simple, take dy dx common, dy dx is common, so it remains only 1 by y, then minus this one, minus 1 is equal to right hand side is simply 1, and therefore dy dx will be equal to, sorry, you may take LCM here, so it is actually 1 minus y divided by y is equal to 1, and so dy dx is equal to, by taking just cross product, y by 1 minus y. So that is the proof, you may write proved. That is the solution of the question. Again you see, if you do not take logarithm here, then it can also be done like this. You see here, by direct differentiation, dy dx is equal to derivative of e to the power x plus y is simply e to the power x plus y into the power function derivative is 1 plus dy dx. It will be like this, and then implies dy dx. In the solution part you see the expression, in the expression we are to prove there is no x, and that is why in this total expression you have to convert all the terms in terms of y. So this e to the power x plus y, in the question you see e to the power x plus y can be replaced by y again, and therefore this is y into 1 plus dy dx. So it is actually y plus y into dy dx. Then shifting to the left, it is dy dx is common, and it will be 1 minus y. This is shifting to the left, equal to y, and so the answer will be dy dx equal to y by 1 minus y. So answer will be same. So you may opt for this method or this method. So this completes the solution for the question. You take another question. This is your question. Y is equal to sin x divided by 1 plus cos x divided by 1 plus sin x divided by 1 plus cos x divided by, and so on up to infinity. So in this question you see, to prove that this is the expression given, you have to prove this one. So therefore first of all you write the given expression. It is y is equal to, so y is equal to this one. First of all you see from where the series is again repeating. You see y is equal to, it is beginning from sin x divided by 1 plus cos x divided by 1 plus sin x. From here it is repeating. From here it is repeating. Therefore if you eliminate all this term, then this remaining term can be considered as y. So this can be actually written as y is equal to, sin x is remaining same, you see here very sincerely, 1 plus this cos x remaining, because repetition is not beginning till now, divided by 1 plus, from here it is repeating, therefore this total term can be replaced by y. So this is your expression actually. Now this can be done like this. Y is equal to, taking LCM here, and we'll go to the numerator. Therefore it is 1 plus y is here into sin x divided by, it will be 1 plus y plus cos x only. You can directly differentiate here, but it will be easier if you take the cross product than differentiation. So it is y plus y square plus y cos x is equal to 1 plus y into sin x. Simple cross product. Now differentiate. So differentiating with respect to x. So this is dy dx. We have written here dy dx. Then plus, it is twice y dy dx. Then plus product of two functions. So it is simply dy dx into cos x is remaining same. Then plus, so not plus, it will be minus because derivative of cos is minus. So it is minus, I write here, minus y sin x is equal to 1 plus y derivative is only dy dx. Then sin x remaining same plus 1 plus y remaining same into derivative of sin x is cos x. So this is the derivative of the function. Now you take the terms involving dy dx. So this term, this term, this term, and this term, all terms involving dy dx. So shift to the left, and other terms should be shifted to the right hand side. So you see the next line. So after shifting and taking common dy dx, you will get this line. And then from here dy dx will be is equal to 1 plus y into cos of x plus y sin of x whole terms divided by 1 plus twice y plus cos x minus sin x, and hence the result. So that will be the solution for the question. Again we see another question. So this is your question now. Y is equal to cube root of log x plus again cube root of log x plus again cube root of log x plus up to infinity. Then to prove that dy dx is equal to this one. So in the solution of this question, you see y is equal to, since it is cube root, therefore first of all you take y cube is equal to, this cube root will be eliminated, log x plus the remaining terms, and the remaining terms can be replaced by y. So actually this is equal to y cube will be is equal to log x plus y. The term will be y cube is equal to log of x plus y. Then simple differentiation and you will get the result. So this question is homework for you. You can solve yourself. Okay, you see another question. This is your question. If y is equal to cos x plus 1 by again cos x plus 1 by again cos x, then so on up to infinity, prove that this one. Again you see the repetition begins from here. Therefore it is actually y equal to cos x plus 1 by, this total term is y. So 1 by y. And from there you can solve yourself. So this is also homework for you. If you have any difficulties with the question, then ask me. Okay. So you take another question. You see this question. If y is equal to a to the power x, a to the power x, again a to the power x, and so up to infinity, prove that this one. Y is equal to a to the power x, then repetition is beginning from here. So a to the power x to the power y. Your expression will be y is equal to a to the power x to the power y. And this problem can be solved by the use of logarithm. So using logarithm you can solve the problem and you will get the answer, this one. So try yourself. If you have any problem with this question, then you can ask me. I will solve the question for you. So we finish the chapter here, and in the next class we will begin the chapter differentiation of parametric function. Actually তোমার বুকত কি আছে, এই যেটো সিমেট্রিক ইনফাইনাইট সিরিজ আমি ডিসকাশন কৰিলো, সিমেট্রিক ইনফাইনাইট সিরিজৰ মাত্ৰ এটা কোৱেশ্যনে দিয়া আছে ইন দা মিসেলিনিয়াস পাৰ্ট একচুয়ালি, এন্ড দা কোৱেশ্যন ইজ y is equal to x to the power x to the power x to the power x এটা কৰিছিল নহয় আমি, সেই কোৱেশ্যনটোৱে মাত্ৰ তোমাক এই মিসেলিনিয়াস পাৰ্টটোত ইনভলভ কৰা আছে। তথাপি আমি ইয়াতে 7-8টা কুৱেশ্যনছ আমি ডিছকাছ কৰিলোঁ তো এইখিনি কৰিলে ছাফিচিয়েণ্ট বুলি মই ভাবোঁ তোমালোকে অলপ 2-এটা কুৱেশ্যন চাবা তোমাৰ যিটো ৰেফাৰেঞ্চ বুক আছে ৰেফাৰেঞ্চ বুকৰ পৰা কিছুমান কুৱেশ্যনছ তুমি চাবা এইটো টাইপত মই ভাবোঁ তোমালোকে কৰিব পৰা হৈ যাবা কাৰণ বেছি টাফ নহয় চেপ্টাৰটো ইয়াতে মাত্ৰ তোমাৰ খালি তুমি কি কৰিব লাগে ৰিপ্লেচ কৰিব লাগে হা ইনফাইনাইট চিৰিজটো এটা ফাইনাইট চিৰিজলৈকে কনভাৰ্ট কৰিব লাগে কনভাৰ্ট কৰি পেলাই তাক ডিফাৰেঞ্চিয়েশ্যন কৰিব লাগে এইখিনিয়ে কথা আৰু গতিকে ইয়াতে আৰু বহুত বেছি কুৱেশ্যন ছল্ভ কৰি আমি সময়খিনি নষ্ট নকৰোঁ তো তোমালোকে কিছু কুৱেশ্যন ছল্ভ কৰিবা মই ক'লোৱে গতিকে আমি নেক্সট ক্লাছত ডিৰাইভেটিভ অফ পেৰামেট্ৰিক ফাংচন চেপ্টাৰটো বিগিন কৰিম এণ্ড ডেট চেপ্টাৰ ইজ ভেৰি ইম্পৰ্টেণ্ট চেপ্টাৰ কুৱেশ্যনছ সেইটো চেপ্টাৰৰ পৰা তোমাৰ ফাইনেল এক্সামত কুৱেশ্যন সুধি থাকে কিন্তু হা ঘনকৈ সুধি থাকে গতিকে সেই চেপ্টাৰটো আমি নেক্সট দিনাখন বিগিনিং কৰিম গতিকে আজিৰ কাৰণে আমি ক্লাছটো ইয়াতে ফিনিছ কৰিলোঁ চ' থেংক ইউ ভেৰি মাছ